Hello and welcome back. We're looking into one more problem in the lesson about multiplication of a vector with a scalar. So let's get started. So in this case, we're given the trapezoid ABCD and the diagonals AC and BD intersect at a point E as indicated. So we're told that AB is 2/3 of DC. So let's take a look at where AB is. So that's one of the bases, the smaller one. And DC is the larger base. And it seems that AB is 2/3 of DC. And I like to write or organize the information when proving statements, especially in geometry, into given and prove. So ABCD is a parallelogram, and we are told that AB is 2/3 of DC. Now we need to prove this statement here. So AE equals 3/5 of AB plus 2/5 of AD. I try not to let myself be confused by the complexity of the statement. So just try to take it easy, stay calm, because that's the best way to approach solving any problem, not just math. So first locate where the information is. So what we are trying to work with is AE, and then AB, and then AD. So it seems that the vectors that we're trying to connect in here are on this side of the diagram. So we're going to try to focus on expressing this vector in here in terms of these other two sides. Now, remember that AE is actually part of the diagonal AC. So I am going to start off by working with the diagonal AC. And we'll say that the diagonal AC equals AD plus DC. So AC is AD plus DC. Now, I am going to actually keep the AD in because I do want to express or have AD in my statement. But I'm going to look into DC and see what I can replace it with. And when I think of replacing DC, I need to replace it with something that is in the statement. So the other vector in the statement is vector AB. And I see that I'm given some information about the connection between DC and AB. And we're going to say that if AB equals 2/3 of DC, then we can derive that 3AB equals 2DC. So how does that happen? So remember that this is a fraction, right? So 2DC divided by 3. And this is also, or it can be a fraction with denominator 1. We simply cross multiply and we get 3AB equals 2DC. So this will allow us to express DC in terms of AB. And we want to bring AB in the statement. That's the reason why. So that would be 3/2 AB. So I'm kind of happy with this. So I will substitute DC by 3/2 AB. And I'm going to leave AD where it is. Because again, these are vectors that I like to have in my statement. So AB and AD. So I'm happy with my right side. So let's take a look at AC. So what can be done about this? So this is vector AC. And in vector AC, we have AE, which must be included in our statement, the statement we're proving, and EC. So I will write vector AC then as the sum of AE and EC. Now, obviously, I do want to have AE in this statement because that's what I'm trying to prove. So, which means that I have to work with EC. Now, one little thing that takes a little bit of time and practice and intuition to figure out is how to express EC in terms of AE. And this is when this is where the geometry knowledge from back in grade 9 will help us. So here we go. Notice that here we have two parallel sides, AB and DC. Now, the diagonal AC will act as a transversal for these two parallel sides, which means that it will create two alternate angles equal to each other. Now, in a similar way, these two parallel sides are intersected by the transversal BD, which will create these two equal angles. So angle E here and angle E and here are also equal because they're opposite. So that tells us that this triangle ABE and this triangle here BCE are two similar triangles, or they have the same shape. So I am going to state the similarity down here, and I'm going to say that the triangle ABE, and hold your breath now because I want to explain you or recall something very important. It's simple, but it helps a lot. So when we state the similarity of triangles, don't know if you remember or not, it is best that we list the similar triangles based on the angles, on respective equal angles. So what does that mean? So if we started with angle A for triangle ABE, then we'll start with the angle that is equal to angle A in the other triangle, which means angle C. And then the next angle here is angle B. So equal to angle B would be angle D. And then the last angle is E. So we're going to say that now that we have stated similarity of triangles, we can build the ratios. So we'll say that AB, and look at how easy it becomes to state the ratios now that we have ordered the angles respectively. So AB over CD, and we're only talking about their magnitudes, obviously, so the lengths, equals BE over DE. So BE over DE. Again, that's the magnitude. And that would equal vector AE over CE. So the magnitude. So remember that since we're told that there is a connection between vectors AB and DC, given by this statement here, then we can derive that the magnitude, so I'm going to write down the explanation. So since AB equals 2/3 of DC, then we can say that the magnitude of AB over the magnitude of DC must equal 2/3. So this ratio here is 2/3, but so should this one, and so should this last one. And this is the one we're interested in, so 2/3. So we'll say that the magnitudes of vectors AE and CE stand at the ratio of 2/3. This is one ugly arrow. So we're going to say that vector AE over vector EC, I'm going to align them based on the direction, so AE and EC. So the ratio stays positive, must be 2/3. So that will make vector EC, or I'm going to follow the long way here just for the purpose of explaining. So cross multiply, and we get 2EC equals 3AE. So that will make AE, EC better. That's what we want to get rid of. So vector EC will be 3/2 AE. So patients, we're almost at the end, and I know that we went too far. So let's go back to where we were. So our statement was AC was AD plus DC. So AD plus DC. So we want to keep AD in, so we kept AD. But then we replaced DC. And we replaced DC, which is this vector down here, with something AB, because we already know AB is 2/3 of DC. We go DC 3/2 AB, so that's what happened here. Now, on the other hand, we took AC, and expressed it as AE plus EC. So AE plus EC. Now we want to keep AE on the left side, but we want to work with EC. Try to express it in terms of AE. Now, due to the similarity of these two triangles, it seems that the ratio AE over EC is 3 over 2. So EC is 3 over 2 AE. So now we can replace EC with something AE here. So now it's the moment. So we're writing AE. So we're going all the way here. Plus, again, instead of EC, that's why we did all this work in here, we have 3 over 2 AE equals AD, which was already there, and then plus 3 over 2 AB. So if you look at our statement at this point, we have only AEs on the left, ABs and ADs on the right. So all we have to do is simplify. So 1 AE plus 3 over 2 AE is the same as if saying 2 AE over 2. So that makes it 5 over 2 AE equals AD plus 3 over 2 AB. Now it becomes a matter of simplifying. So if you want to actually isolate AE, you multiply by 2 over 5 everything. Right? The reciprocal of 5 over 2, which will give AE a coefficient of 1. That's what we want. That would be 2/5 of AD. Plus, these 2's will simplify 3/5 of AB. And voila! This is the statement we wanted to prove. I hope that you enjoyed this lesson and the explanations, and I hope you found them useful. Bye for now.